Hi everyone, today we're going to study combinations. Let us define combination. A combination is a selection of all or part of a set of objects without regard to the order in which objects are selected. This is our formula. The number of combinations of n objects taken R at a time is this. We're going to use the symbol NC sub R. And this is equal to the fraction where the numerator is n factorial and the denominator is n minus r, then factorial multiplied by r factorial. Take note, the number of combinations of n items taken all at a time is 1. Let us see some examples. Example 1. Compute, letter A, combination of 5 items taken 3 at a time. Letter B, combination of 7 items taken 3 at a time. First, let us write our formula. Let us begin with letter A problem. 5C3 equals, using our formula, this is 5 factorial over the denominator 5 minus 3, then factorial, times 3 factorial. First, let us simplify the expression in the grouping symbol. The 5 minus 3 becomes 2. And then let us simplify the factorials. In the numerator, we have 5 times 4 times 3 factorial. In the denominator, the 2 factorial becomes 2 times 1. And the 3 factorial, we will keep it as is. Because we can see here that we can cancel this 3 factorial and the 3 factorial in the numerator. There we go. Simplifying further, the numerator becomes 20 over the denominator is 2. And the quotient will give us 10. This is the combination of 5 items taken 3 at a time. Let's proceed with problem B. 7 items taken 3 at a time. This is equal to 7 factorial over 7 minus 3, then factorial times 3 factorial. Let us simplify. The 7 minus 3 will give us 4, and then let us simplify the respective factorials. On top, the 7 factorial becomes 7 times 6 times 5 times 4 factorial. In the denominator, we keep the 4 factorial as is, and then let us expand the 3 factorial as 3 times 2 times 1. We can cancel the 4 factorial in the numerator and in the denominator respectively. And then simplifying further, the numerator gives us 210 over the denominator, which is 6. So 210 over 6 equals 35. This is the combination of 7 items taken 3 at a time. These are the final answers. Let us see example 2. In how many different ways can a student select to answer 5 questions from a test that has 7 questions if the order of the selection is not important? For our solution, since the order is not important, it is a combination problem. Thus, we write combination of 7 items taken 5 at a time. Using our formula, this is now equal to 7 factorial over the denominator 7 minus 5 factorial times 5 factorial. Let us simplify the 7 minus 5. This is now 2. And let us now simplify the respective factorials. Our numerator can be written now as 7 times 6 times 5 factorial over the 2 factorial is now expanded into 2 times 1 times the 5 factorial. We will keep it as is because we can cancel the 5 factorial in the numerator and in the denominator. There we go. So in the numerator, we have now 42 over the denominator, which is 2. And the quotient will give us 21. This is our final answer, where 7 items is taken 5 at a time. Let us see example 3. How many line segments can be drawn by connecting any 2 of the 6 points that lie on the circumference of a circle? For our solution, since the line that goes from point A to point B is the same as the one that goes from B to A, this is a combination problem. It is a combination of 6 objects taken 2 at a time. Therefore, we can write 6C sub 2. Using our formula, this is now equal to 6 factorial over the denominator 6 minus 2, then factorial, times 2 factorial. Let us simplify first. The 6 minus 2 will give us 4. Then let us now simplify the respective factorials. Our numerator can be written as 6 times 5 times 4 factorial. In our denominator, we will keep the 4 factorial as is. Then let us simplify the 2 factorial into 2 times 1. We can now cancel the 4 factorial in the numerator and in the denominator. So here we go. And in the numerator, we have now 30 over the denominator, which is 2. And the quotient will give us 15. This is the final answer. Let us see example 4. There are 10 people at a party. If they all shake hands, how many handshakes are possible? In this case, we note that between any 2 people, there is only 1 handshake. It means to say, we're going to write combination of 10 people taken 2 at a time. Using our formula, we have now 10 factorial over the denominator 10 minus 2 factorial times 2 factorial. Let us first simplify the 10 minus 2. It will give us 8 factorial. Then let us now simplify the respective factorials. the numerator becomes 10 times 9 times 8 factorial. Over the 8 factorial, we will keep it as is, and let us expand the 2 factorial, which is now 2 times 1. We can now cancel the 8 factorial in the numerator and in the denominator respectively. So now, we can now simplify our numerator to be 90, that is 10 times 9, over the denominator, which is now 2. 90 divided by 2 is equal to 45. So it means there are 45 possible handshakes in a party of 10 people. This is our final answer. I hope you learned something from this video. See you again next time.